Alright, so hey guys, right now it's pretty late, so I won't be speaking so loudly. I'll be putting the mic closer to my mouth, like that, okay? So, for the last problem of the day, we're looking at example 4. Basically, it's asking us to prove Euler's theorem in geometry, because Euler made a lot of theorem before. So this is the specific one to geom. And basically it says that when the circumradius and inradius of triangle ABC are big R and small r respectively, and d is the distance between the circumcenter and the incenter, d squared equals to this. And basically these two forms are equivalent because you just square root both sides. And when ABC is equilateral, basically the distance between circumcenter and incenter is 0, because when ABC is equilateral, the incenter is the circumcenter. So D should be 0, so R should be equals to 2 small r, and make the whole term 0. So let's just start to prove this. Basically, let's first draw the diagram, okay? Since this is talking about triangle, incenter, and circumcenter, we need, first of all, a diagram to know at least what we're looking at and what we're working with. So we have this, okay? And let's draw the triangle. So this one is ABC. We can draw in the in circle. Oh my god. Okay. It's not working, bro. Okay, this kind of works now. So this is the incenter, this is the circumcenter. Hold up. Circumcenter is O, the distance is D, and yeah, okay, so let's just draw the lines like this. This point will touch at D, where D is the midpoint of arc BC, based on the definition of what an incenter does. Okay, so this line, note that all this bisects ABC. Okay, so let's connect D and O. Let's use another color. D, O, here's M. Okay, and I think that is all we need. Okay, so here, right, let us split. Since the red dotted lines bisects A, B, and C, let us just denote what it bisects into, okay? So, for example, angle BAC, right, let us make it equals to 2 alphas, okay? So, angle A equals 2 alpha, and angle B equals 2 betas. So this is alpha, this is a beta. Yeah. Okay, so now I want you to consider angle IBD. So IBD. Okay, IBD, basically in this angle that we're considering, we know that this is confirmed beta, but we just don't know this. Well, by considering this angle and this angle, we know that this is equals to angle this. Okay, so this is alpha, same as DAC, which is also alpha. Okay, so now what is beta? We know that, my bad, angle IBD equals beta plus alpha. Okay, what is also beta plus alpha? Well, this one. This, let me just use another color. This one is also beta, this one is also alpha. And which angle is equal to the two green angles added up together? It is this exterior angle, angle BID. So angle BID is also beta plus alpha. So this one is beta plus alpha. Since angle IBD equals to angle BID, implies triangle DBI is isosceles. So BD, my bad handwriting, it's 1 a.m. equals to IAD. We need this, okay? So this is equals to this, and now we use power of a point theorems. Since right now we still haven't used power of a point theorem yet. The power of point I, let's consider power of point I. Power of point I is equals to what? R squared minus D squared. Since D is the distance between O and I, so this is supposed to be OI squared, but we just use D squared. Okay, which is, okay, first of all, you need to know that this is a way to express power of a point I with respect to the bigger outer circle. Another way to write power of a point I, there are two ways to write, is with respect to the chord AD, which is equals to IA times ID. So these two are just two ways to write power of a point I with respect to a big circle. Now, again, let's equate this to something. So IA and ID, right? First, let's take a look at IA. We want to find out what IA is, first of all. So IA is this length here, right? If you drop a perpendicular down from I to AB, the length of this perpendicular would be the radius of the in circle, which is small r. Okay, so let's side note this. Considering this triangle, right, with a right angle here, we have sine alpha equals to O, which is R, over H, which is IA. So rearranging to get IA as subject, we get IA equals R over sine alpha. So let's just write this down. IA is R over sine alpha. Then we times ID. Now we take a look at ID. What is ID? Okay, so ID is this one, right? We know that ID is equals to BD because it's isosceles. Now let's look at BD. BD is a side on the triangle ABD. And this side BD has an opposite angle of alpha. So by sine rule, on triangle ABD, so side note again, BD over sine alpha equals to 2R. This is the extended sine rule. So BD equals to 2R sine alpha, and hence ID is 2R sine alpha also, due to isosceles. So you times 2R sine alpha, and you realize that sine alpha and sine alpha cancel out. You get 2R, R, big R and small r. So R squared minus D squared equals to 2 big R. You rearrange D squared. The thing is, you have to look at what you want to prove. You want to prove that D squared equals something, so you rearrange to get D squared on the left hand side. R squared minus 2 big R. You factorize out R, you get R minus 2 small r. And this is shown since we got the exact form that Euler's theorem wanted. And yeah, that's all for this question. So that's about it. Thank you.